Right, so you might think you already know how to multiply matrices because you know how to add and subtract them, and that was really easy. But actually, you've got no idea how to multiply matrices. That's because matrices do not behave like numbers at all when you multiply them. What do I mean by that? Well, I mean this. Numbers are commutative under multiplication. Now, what does commutative mean? It just means that 2 times 3 is equal to 3 times 2. In other words, order doesn't matter for numbers. 2 times 3, 3 times 2, same thing. But for matrices, matrices are not commutative under multiplication. That means that A times B does not equal B times A, which means order does matter for matrices. So A times B not equal to B times A, obviously where A and B are matrices. All right, let's do 2 examples that I hope make this point really, really clear. So I've got 2 examples here. We'll call this example 1 and we'll call this example 2. And in both cases, they're going to use matrix A and matrix B. The first example says find A times B. Now let's go through our 5 steps of matrix multiplication. First up, let's determine the size of each matrix. Now, A has 3 rows and 3 columns. So we can say that A is a 3 by 3 matrix. And B has 2 rows and 3 columns. So we can say that B is a 2 by 3. Now, the next question we ask ourselves is, can this multiplication be performed? Because not all multiplication can be done here. And the way that we test it is by looking at the columns of the first matrix and the rows of the second matrix. And if they're the same, then we can do the multiplication. Now, in this case, 3 is not the same as 2. Therefore, can this multiplication be performed? No. So that means that we can ignore step 3, 4, and 5, and we can just say A times B does not exist. And that's the end of that question for us. Now, what about this second example? Find B times A. Now, I can determine the size of each matrix. Now, I know that B, because I'm going to do B first, right? So I know that B is a 2 by 3 matrix. And I know that A is a 3 by 3 matrix. And then the question is, can this multiplication be performed? Well, I look at the columns of the first matrix, I look at the rows of the second matrix, and I say 3 does equal 3. Therefore, yes, I can perform this multiplication, and so now I need to get to work doing this multiplication. All right, so what's my next step? Mark up an empty matrix of the correct size. Now, what's the correct size? Look back at where we've marked up our matrix, and we use that as our guide. So the outer things here, the 2, the first number in the first matrix, the rows of the first matrix, and the columns of the second matrix, that's going to tell us the size of our new matrix. So matrix BA is going to be size 2 by 3. All right, so now I'm going to mark up a matrix that is size 2, 3. And make it really, I'm going to make it really big here because we're going to do a lot of maths in here. All right, so it's going to be a 2 by 3 matrix. So it's going to have an element here, 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 and an element here. And what I'm going to do is label all of these elements with their positions. And that might seem a bit wild, but you'll see why in a minute. Now this element is row 1, column 1. This element is row 1, column 2. This element is row 1, column 3. This element is row 2, column 1. This element is row 2, column 2. And this element is row 2, column 3. Now that I know that seems like, why on earth would you want to do that at this point, but it's going to make sense, I promise. Okay, so now we're going to write in all of our calculations for every single element. And these little numbers here, this 1, 1, this 1, 2, this 1, 3, that's going to be a really good guide for us on how to do that. So this first element here is going to be equal to row 1 times column 1, row 1, column 1. So it's going to be 1 times 0, 1 times 0, plus 2 times 3, plus 3 times negative 1. Okay, this next element is going to be equal to row 1 times column 2. Row 1 times column 2. All right, so again, let's write that in. It's 1 times 1 plus 2 times 4 plus 3 times negative 2. And then this next element is going to be row 1, column 3, row 1 times column 3. So let's do that. It's going to be row 1, oops, that's a disaster, times column 3. All right, so let's just put that in now. So it's 1 times 2 plus 2 times 5 plus 3 times negative 3. Okay, and then we just run really quickly through the other 3 there. So I might just get rid of all my highlights because that's just making my life really hard now. And do it all over again. So this is row 2 times column 1, row 2 times column 1. So that's 0 times 0 plus 4 times 3 plus 2 times negative 1. And then it's row 2, column 2, row 2, column 2, 0 times 1 plus 4 times 4 plus 2 times negative 2. And finally, rub those out. It's going to be row 2 times column 3. 0 times 2 plus 4 times 5 plus 2 times negative 3. So interestingly, it looks like my final matrix doesn't need to be this big now, does it? That's a bit silly. Is going to be 3, 3, 3, and 10, 12, 14. Right, that's matrix multiplication. You can see it's not like numbers, it's a bit special. It's really easy to make a mistake. You might have seen that I made a small mistake there halfway through my working. So you need to take it really, really steady. Think about your work as you go. That's multiplying matrices.